Our quiz for today involves resistance. Here I have a piece of wire. It's a pretty thick piece of wire. And by the way, wires are made often by taking a piece of metal, usually when it's a little bit warm, and you can either pull it or push it through a die, and you're simply going to stretch it out into a nice long wire. Our question today is if I took this wire right here, this wire has a particular set of dimensions, and I simply stretched it so it was twice its length, what would happen to the resistance? So this is what your quiz looks like. As always, please write down your thoughts and how confident you are about those thoughts. And one little hint, it's gonna be the same piece of wire. All I'm doing is stretching it out. Give that a whirl. All right, often students can get this one simply by thinking through the length issue. We know that if a tunnel gets twice as long, or if a garden hose gets twice as long, it's twice as hard to get through it. They can use their analogies to build it. This is twice the length of our original wire. One of the key points here is that we can also bring equations into kind of our gut feeling and our intuition about resistance. And that's what you want to do. If students can get this qualitatively and kind of think through it using their analogies, see if you can push them a little bit further so that they can start to develop the ideas of mathematics and using equations. Let's go a little bit further here. And by the way, this one certainly would have more resistance, but how much more? So one of the keys is we know the volume, the amount of stuff in our wire is the same before and after. So this one has a particular volume, and we know that it's going to be equal to this volume. We also know that volume is 3 dimensions. I can take the area and its length, multiply. I could put a where statement here, so make that crystal clear. Volume equals area times our length. Well, if this length becomes twice as big, the only way to keep the same volume is if we have the area. So in this case, I could say, well, I would have a smaller A and a bigger L. And I could put numbers on these if I'd like. I could say, if this was 1 and this length was 1, just arbitrarily picking them, I could say, well, this one must be 1/2, and this one would have to be 2. So I still have the same exact quantity. 1/2 times 2 still equals 1. 1 times 1 equals 1. That helps us when we're using our resistivity formula. And we know that resistivity is going to be giving us our overall resistance if we have the resistivity times the length divided by the area. Now in this case, both sides are going to have the same exact row, so that's really not going to factor into this at all. It's going to be the length divided by the area on each side. So I could say, well, the resistance on this side is going to end up being resistance equals rho L all over A. I'll normalize these once again. Better yet, I'll write it on the other side too. And we know on this side, I could put it like on this side, I could say, well, I have the same size row. Here, I'm going to have twice the length, and I'm going to have half the area. So that's another way to put this. Now we can answer the question here. What is this resistance going to be? I don't want to write it because, well, we certainly know it's going to be bigger, but how much bigger? So how much bigger would that R be than this R? Well, our rows are the same, so they're constant. We know that this letter and this letter will cross out, area and area will cross out, and I'm left just with my numbers here that will say I have 2 all over 1/2. Another way to write that is simply to say I've got 2 all over 1 all over 1/2. Because when I take 2 divided by 1, it's still 2. Now I can play a little trick. I can get the bottom, the reciprocal of the bottom, and multiply it. Reciprocal over reciprocal makes the number 1. So I can put 2 all over 1, and then I can put 2 all over 1. That's a trick to get rid of everything on the bottom, and then I'm simply left with 4 all over 1, which is 4. This wire stretched twice the length and having half the area would have 4 times the resistance. That's your quiz for today.